Our topic today is about momentum. Momentum. What is momentum? Momentum is the product of mass times velocity. Momentum equal mass times velocity. Its units will be kilogram meter per second. Why momentum is important? I'm going to explain now the importance of momentum. If a mass m was moving with a velocity u under the action of a force F, and because of the force its velocity increased, and after a time t its velocity is v. What is the change in momentum? The change in momentum will be equal to the final momentum minus the initial momenta. The final minus the initial. We subtract mv minus mu equal to m v minus u. But v minus u, we know that v equal u plus at. If v minus u equal at. If instead of v minus u we write at, mass times acceleration is force. Force times time. This quantity, force times time, is called impulse. Its units is Newton second. Yeah, but the importance of momentum is this, that change in momentum equal impulse. This is an important equation in our M1 course, that impulse is the change in momentum. And impulse and change of momentum, they have the same units, which is Newton second. Remember that momentum is a vector quantity. Therefore, when we solve problems, we should be taking care of directions. Let us have very simple examples. Now, in the book, example number 2, it says, a body of mass 2 kilogram is at rest on a smooth horizontal plane a horizontal force of 4.5 Newton act on the body for 6 seconds. Therefore, it gave it an impulse. As a result, the mass will be moving with a velocity v. How much is the impulse? The impulse is 4.5 times 6. It is force times time. The answer is 27 Newton second. Impulse equal a change in momentum. But that impulse 27 equal mv minus u. The mass is 2 kilograms, the velocity unknown, and the initial velocity is 0. From this equation, we get the velocity equal 13.5 meter per second. Let us have another example. Example 3. It says here that a ball is going to hit a wall. This is the wall. A ball of mass 0.2 kilograms was moving toward the ball with a velocity of 3.5 meter per second. When the ball hit the wall, it's going to bounce back with a velocity. Diagram shows, right? It bounces back with a velocity 2.5 meter per second. We wanted to find the impulse given to the ball. Now we say impulse equal a change in momentum equal mv minus u. Equal the mass 0.2, 2.5 minus 3.5. Therefore 0.2 times 6. Therefore this is equal 1.2 Newton second. Remember, now by the way, this is the impulse of the wall on the ball. It is also the impulse of the ball on the wall. This is because of Newton's third law. The two forces are equal and they are for the same time, even therefore the two impulses are equal. This is a fact we have to know without knowing any reason. We have to know that impulse is the same between the two bodies. Any two bodies colliding, impulse between them is the same. Impulse of A on B, the same as B on A. So we don't have to care about this because this is a fact. The important thing from these two examples, I would like to say this, that when we calculate impulse, if the two velocities are in the same direction, assuming that this body at rest, it has a velocity 0 to the right, and now it has a velocity v to the right, then two velocities are in the same direction, then impulse equal the mass times the difference between the two speeds. The larger minus the smaller. But when the two velocities are in opposite direction, actual fact, we add the two velocities, not subtract them, because minus minus is plus. And therefore, for sure, we say this, that this body, this mass, right, because the direction of the velocity have changed, therefore, when we calculate impulse, we add the two velocities. We will see this in later examples. The important type of problems we are going to have is the problem when two masses collide together. When a mass m1 moving with a velocity u1 collide with a mass m2 with a velocity u2. This is before collision. And after collision, the mass m1 will move with a velocity v1, and the mass m2 will move with a velocity v2. The two velocities at the top are before collision, and the two velocities at the bottom are after collision. Now, we have a principle saying this, that the momentum is conserved, the total momentum before impact between the two masses and after the impact is the same. We don't have to write this in words, but we can say, because of, we just can write for the free, for once only this time, we say conservation of momentum. M U1, M1 U1 plus M2 U2 equal M1 V1 plus M2 V2. This is the important equation which will solve our problems. Let us have an example. Example number 4. A particle P of mass 2 kilogram, a particle P of mass 2 kilogram, moving with a speed 3 meters per second, and a particle Q of mass 3 kilogram at rest, and a particle Q of 3 kilogram at rest, means its velocity is 0. Particle P collides with particle Q, and after collision, Q moves. This is P, and this is Q. Q is going to move with a speed 7/3. We don't know the speed of this particle. The speed of this particle is v. We want the speed, no, the speed of that particle, right, and its direction. Any velocity we don't know its direction, we consider it positive unless otherwise is proved. So we consider that velocity is positive, right? We consider it as positive until we prove the opposite. Then we write this conservation of momentum. We don't have to write the statement again. We'll just write it straight away. 2 times 3 plus 3 times 0 equal 2 times v plus 3 times 7 over 3. 2 times 3 is 6 plus 0 equal 2v plus 7. So we get 2v equal -1. So v equal -half. This means the particle P will move to the left. Its direction change, yeah, but and its magnitude, the magnitude of its velocity is half. And therefore we say in magnitude half and direction reversed. And direction reversed. Because it used to move to the right, now it is going to move to the left. This is an example, first example, on collision of two particles. When two particles collide, he is going to ask about the impulse. When we consider impulse, we consider only one of the masses, either P or Q. We are going to consider P, so the impulse on P is going to be its mass, 2, we say mv minus u. I have always tried this rule. Then the mass is 2. The two velocities are in opposite direction. And because the two velocities are in opposite direction, we add them, either 3 plus half. Therefore, the answer is 7 Newton second. By the way, this is the impulse of P on Q, and it is also the impulse of Q on P. Now we consider the next example. Now, the next example is example 5. What example 5 is saying? Saying that two particles A and B of masses 2 and 4, this is example 4 in the book, a mass of 2 kilograms is moving with a velocity of 3 meters per second, right? He said they are moving toward each other. The other particle is moving in the opposite direction. The other mass is 4 kilograms. And it is mentioned that it was moving in the opposite direction with a speed 2 meters per second. We always put the velocity before at the top and the velocity after at the bottom. After what you say here, after collision, the direction of motion of A is reversed and its speed is 2. The A, its motion is reversed with the speed 2. we don't know in which direction this velocity is moving. So since we don't know it, right, we give it a positive direction, and we call this velocity is v. Any velocity unknown, we give it a positive direction. Now we apply conservation of momentum. 2 times 3 plus 4 times negative 2 equal 2 times negative 2 plus 4v. 6 minus 8 equal negative 4 plus 4v. Therefore, we got 4v equal 6 plus 4 minus 8 is 2. Therefore, v equal half meter per second. And since the answer is positive, if the direction we gave is correct, means the 4 kilogram would be moving to the right, means we say in the mass, the 4 kilogram velocity, velocity is reversed. So when you say give direction of the motion of, we say direction of motion of B is reversed. Why? It was moving to the left, now moving to the right. Now we come to calculate the impulse. To get the impulse, it said in the question, what is the impulse given by A to B? Yani you wanted to consider particle B. Okay, impulse of 4B. We write the rule mv minus u. We say this is equal the 4 kilogram. The two velocities are in opposite direction. Therefore, we add them. 2 plus half. The answer is 10 Newton second. We will get the same answer if we consider the other mass. Let us try. Just is not required, but let us try. We say, what is the impulse for A? Again, it's mass times V minus U. We just try to show the rule, but now we come to the actual thing. The mass is 2 kilogram, and the two velocities are in opposite direction. So we add them. We add them 2 plus 3. The answer is 10 Newton second. We must get the same impulse. The impulse is the same between the two masses. This is a must. Don't need to do this, but just to confirm. Right, and we say the impulse, the magnitude of the impulse is 10 Newton second. We will not be asked to give direction of the impulse. I say this again. You will only be asked to get the magnitude of the impulse, but we will not be asked to find the direction of the impulse. Let us take the next example in the topic. The next example is an interesting example. I remind you one thing is when, for example, because this is something we hear in mechanics, we are modeling their problems. If, for example, a car is towing another car, they connect between themselves a rope. And then what will happen is this, that the rope is slack, and then the car is the unbroken car will start moving, and once the string becomes tight, its speed is reduced. Why? Because the momentum it has should be shared between the two bodies, because now we used to have only one body moving, so one momentum. But now the two masses are moving, if its momentum is going to be shared among the two. This means the velocity of the particle will drop. This is exactly the same as this example. Two particles P and Q, two particles P and Q. Particle P of mass 8 kilogram is moving with a velocity, particle P 8 kilogram is connected to particle Q 2 kilogram. They were connected with the string slag. And all of a sudden, the mass QP will start moving. Now it will, right, the mass 8 kilogram was moving with a velocity of 4 meters per second at the instant when the string became tight. At that time, that one has a velocity 0. Once the string becomes tight, the two masses will be moving with the same velocity. Why? Because the string is tight and there are two connected particles. This means they have the same velocity. Now we have conservation of momentum. The 2 kilogram with a velocity 0 plus the 8 kilogram with a velocity 4 would equal 2v plus 8v. 32 equal 10v. This means the velocity is 3.2 meters per second. This means once the string becomes tight, the two particles are moving with a velocity 3.2. This is the combined velocity after the string becomes tight. Now, we would like to know the impulse. It's asked to find the impulse. The impulse I, we should apply to any of the masses. If we apply the impulse to the left mass, 2 kilogram, then the two velocities are in the same direction. We subtract the larger minus the smaller, which means 3.2 minus 0. The answer is 6.4 Newton second. Now, if we repeat the same thing for the other mass, is not needed in the question, but for yourself to check, you are going to say I equal. The mass is 8. The two velocities are in the same direction. You subtract the larger velocity minus the smaller velocity. So you write V4 minus 3.2. So you will get 6.4 Newton second, because it is the same impulse between them. Right? Now, we have another example. Two particles, A and B, right, are moving toward each other in opposite direction. Right. Now, a mass of A, 2 kilogram, and B, 4 kilogram, are moving toward each other. Their speeds were 3 meters per second, and the other one is 2 meters per second. And we are not given the velocities after collision. This is V. Since the velocities we don't know, we give them the positive direction. I say again, since the velocities are not known, we give them positive direction. And since we have two velocities unknown, we gave one V1 and the other V2. It is given to us that the impulse, right, is 7 Newton second. And we are asked to find the values of V1 and V2. We say impulse to any of the masses. If we apply the impulse to the mass 2 kilogram, if we consider it 2 kilogram, we say 7 equal. I will say impulse equal m v minus u. 7 equal the mass 2. The two velocities are in the same direction. We must know one fact. When two bodies collide, the body on the left, like when a car collides with another car, the car behind, its velocity drops, and the car after, its velocity increases. Certainly this happens. The car at which is the one hitting, when in the hit, its velocity will decrease, and the other car, its velocity will be reduced. Yani, this first car, its velocity will be reduced, and the second car, it was moving in that direction. And when the velocity reduced means its velocity increased. Therefore, we should take this as a fact. The one on the left, its velocity is reduced, and the one on the right, its velocity increased. Since the one on the left, right, let us say the leader one, when it is on the left, is hitting, therefore its velocity is reduced, which means V1 must be less than 3. Therefore we subtract the larger, 3 minus V1. 7 equals 6 minus 2V1. 2V1 equal negative 1, so V1 equal negative half. This means the 2 kilogram, its velocity is reduced, is half, and it changed, and we say its direction, okay, direction of motion reversed. We go to the 4 kilogram. The same 7 equal the mass 4, the 2 velocities in opposite direction, so we add them, 2 plus v1. يبقى 7 equal 8 plus 4v1. 4v1 equal negative 1, therefore v1 equal negative 1 over 4. Negative means to the left, means its direction of motion the same. يبقى direction of motion unchanged. It was moving to the left, it is now moving to the left. This is how you answer, you solve problems when impulse is given. I say this again, when impulse is given, you say impulse equal mv minus u. But remember that for the body on the left, its velocity is reduced. Therefore, you subtract the initial minus the final. Now, for the other body, its velocity is the 2 velocities are opposite direction, so we just add them. To check that our answer is correct, we can do one thing. This is additional to the problem. We can check that the total momentum before collision equal total momentum after collision. Before collision, what is the momentum? 2 times 3 plus 4 times negative 2. This is equal negative 2. After 2 times negative half plus 4 times negative 1 over 4 equal negative 2. Therefore, yes, our solution is correct. The total momentum before and after is the same. Therefore, remember this. When you apply conservation of momentum, we take care of the directions and the plus and the minus sign. To the right is positive, to the left is negative. This is our principle. And we take direction into, we take care of directions in the calculation. If the velocity to the right is positive, to the left is negative. And we calculate the total momentum before equal after. But when you calculate impulse equal, yes, equal mv minus u. But when you actually do the calculation, because it is also always required in magnitude, you don't want the direction, want magnitude. Therefore, what we do is we put the mass, and then if the 2 velocities in the same direction, we subtract the larger minus the smaller. If the 2 velocities are in opposite direction, we add them. And which is larger? Always the mass to the left, its velocity is reduced in collision, and the mass to the right, its velocity is increased in collision. And this is how we solve problems. This is the end of the topic.